you're looking at the rules for parallelograms. And the tricky thing about problems like this, when you see something like this in your homework, is that you can't just go in any order. You have to find one that you can solve for first. And then that gives you clues to find the next one, and so on. Okay, so while you're looking at this, I want you to think of, do you have enough information to figure out 1 first, or 2 first, or 3 first? Okay, you could have enough information to find 3 if you did one thing. Can you tell me what you could do? Vertical angles. Who said that? Was that you?
Yes.
Good job. I was like looking for people who are sitting down. 81 degrees, vertical angles right there. Excellent. And then when you look here, what do you have? What is that? You know what that is. What is that? Triangle, thank you. And what do you know about the degrees of a triangle? 180. So take your calculators and take your 81 degrees and your 37 degrees and subtract from 180 so we can figure out what degree would be. What does it come to? You don't have to rewrite that. You have all that right here. I just put it up on the board so that I have access to show you. Again? No. We'll do just these problems that we practice. These diagrams. That you already have. Okay, so what do we get for 3? Subtract 180 minus 81 and minus 37. You guys are tired. I'll do it. 180 minus 81 minus 37. I get 62 degrees. Okay, any questions about that one? I say that number 2 is pretty easy to find. Does anybody see the way? Help me to figure out angle 2. 180 minus 81. That's a linear pair. Right here is a linear pair as well. So do 180 minus 81. Tell me what you get. 99? So angle 2 would be 99 degrees. Now angle 1 is really easy as well, as long as you can see something there. No, that's kind of the right idea. Alternate interior angles. So it's the other one. Remember, lines are parallel in parallelograms. So this angle on this side is equal to this angle on that side. Alternate interior angles means that this angle is 62 degrees. Okay, there's your 3 missing angles. All right, for right here, let's find number 2 first. This is a straight line of 180 degrees. What would angle 2 have to be? 110. 180 minus 70. I can't figure out this angle without a clue right here. What's this angle right here? 70. Vertical angles are congruent. So now take this triangle and subtract 180 minus 70 and minus 43 and figure out what angle 3 would be. $67? Okay. And if this angle is 67, then look over here. What relationship do you have between angle 3 and angle 1 here? Alternate interiors. So angle 1 would be 67 degrees as well. Okay, you're going to have something like that on your homework, so I wanted to show you something. Try these 2. Decide if you want to try them on your own or we should try them together. Let's discuss it at least. Okay? Angle 1, it's alternate interior angle 2, but we don't know what angle 2 is. Once we find one of them, the other one will be the same. But what is this angle right here going to be equal to? All the way across. One what? It's 180 with the sides. Remember, same side angles are supplementary. So if this one's already 40, what does this one have to be? Remember, the same side angles are supplementary. This angle and this angle are supplementary. They add up to 180. Same sides are 180. Same side angles.
You draw that too?
I would if I were you because it'll help you. No, you know what? We can just do these ones out loud. Let's just do these out loud. You can draw it if you draw it fast. So if this is 140, how do I figure out angle 2? Subtract 140 minus 75, and that comes to 65. So what would angle 1 have to be?
Oh, no.
Yep, alternate interior angles right there. Alright, this one really quickly, let's not write it down. What's angle 3? 41, excellent. Alternate interior angles right here. What's angle 2 going to be? Supplementary, it's a linear pair, so 108. And then how do we find angle 1? No, because that's a good question, but 28 and 1 are same side. They're not alternate interior angles. One would have to be on this side and one would have to be on that side. But what do we have right here? The triangle. So do 180 minus 41 and minus 108. Okay, find this angle here from this triangle. Can someone do that really fast? 31? Alright, so you'll have something like that to try to figure out in your homework. Right now, go ahead and turn back to 5-2 notes. So let me show you the last part that we didn't finish. You should have 2 of them drawn there. If you didn't draw 4 of them, it's okay. Okay, theorem on the bottom of 5-2, the one that we left blank the other day. Go actually back to the regular notes and go way to the bottom. Theorems, if 3 or more parallel lines, so I drew 4 parallel lines, and we're going to have pictures of this, so if you don't want to draw this, it's okay, but if you do, that's good too. If 3 or more parallel lines cut off congruent segments, so the lines have to be parallel, and the segments in between have to be congruent to each other. Okay, if you have 4 parallel lines, or 3 parallel lines, or more than 3, and one of the transversals is cut equally, then any other transversal that goes through is going to get cut equally. Okay? So all it's saying is that the lines have to be parallel, and you have to be given or find out somehow that the one transversal is cut equally, then you can say that all of them are cut equally. So like this one right here. This transversal right here would be 3 equal pieces. And this transversal right here would be 3 equal pieces, etc. And this one too. Okay. So the criteria is the lines have to be parallel to start off with. One of the transversals has to be cut up equally. That means all the rest of them are equal. So turn the page and let's look at the examples that I have there for you. Whoa. If you didn't finish copying that, you'll be able to see it when I post it. Okay, so look. If all these 3 lines are parallel and this portion AC is equal to CE, then what other 2 segments are congruent? Name them for me. BD is going to be equal to DF. That's all they're saying. Then BD is congruent to DF. If the lines are parallel and one transversal is already cut up equally, then all transversals will be cut up equally. You can write this right there. This is on the bottom of the next page, if you didn't find it. Okay, so we're going to look at examples that have numbers, because that's what they really want to know, is the lengths of things. So while some people are finishing, the rest of you look down at the bottom there. See if you can figure out what ZU would be equal to. These lines are parallel, and you're told that PQ PQ is congruent to RQ, which is congruent to RS. You're told that. Okay, so ZU is right here. Z. ZU. What would that be equal to? Let's look down the whole entire transversal, okay? Let's look down all the way down here. So you've got 3 equal parts. This part is going to be equal to this part, which is going to be equal to this part. So what would ZU right here, which part, what would that be equal to? Look at the rest of them. Yeah. Ignore this for a second. Ignore this part of the picture. And ignore the bottom part. And just focus on that transversal right there. Okay? And what number would it be equal to? 3. That's right. Because once one transversal is cut out into equal pieces, then all of them are. So this transversal is broken up into 3 pieces, and this part of it equals 3. So all 3 of them have to be 3. 3 here, 3 here, and 3 here. So ZU is equal to 3. Try to figure out what WV would be equal to. And to figure that out, all you have to do is find the transversal that WV is on, and figure out what the 3 pieces are. What are each of the pieces going to be? 2.25, 2.25, and 2.25. So the total is 2.25 times 3. Anyone got that on their calculator? Okay, so all you have to do is remember that the transversal is cut up into all equal pieces.